Hey, good morning, students.
Hi, Mr.
How are you?
Find.
Okay. We are going to discuss about today our third
Salam alaikum.
objective,
Hi,
energy
Mister.
diagram for exo and endothermic reactions. Yesterday we studied about what is the meaning of exo and endothermic reaction, bond breaking and bond making process. Any question about first two objective?
No.
Mister,
Yes.
where I can find describe the meaning of exothermic and endothermic reaction in the book.
In the book,
Yes.
page number 100.
Mr. and the end of it.
Yes.
صفحة كم؟
114.
صفحة 321 في المعاني. افتحها
Okay.
تلاقي.
You can open your chemistry book, page number 114 and onwards, you will get there exoendothermic reaction. No problem, open your book. Energy change in a reaction, page 114, unit number 9, 9.1. Did you get now?
What, Mister?
Yes.
Yes. Or you can say the topic number 9, energy change and reversible reaction. Page 114, the 9.1 energy change in a reaction. Yesterday we discussed about this exo and endothermic reaction. Don't worry, later I will show you uh, during the online lessons where is the written. I mean, even yesterday I discussed with you. Did you open now?
Yes.
Okay. So first, see here, we are going to discuss the syllabus actually. First and second objective we finish, and I told you that fifth one also come in your short test. So first and second we finish, and we are going to start today third, fourth, and fifth. So third is we are going to draw the diagram. Yesterday we studied what is exo and endothermic reaction, but today we are going to draw the diagram, energy level diagrams about exo and endothermic reaction, and we will observe that what will happen with the amount of reactant and amount of product. Either it will decrease or increase. And here 1.4 are similar when you draw the diagram for a specific reactions. So I will show you example, the normal diagram, and then specific reaction that using a data provided, mean any equations given to you, you will check first. Like yesterday, you saw either reaction is exothermic or endothermic. You saw the like some equation. Okay, so you can find out first is this reaction is exo and endothermic. Then according to that reaction, you need to draw the diagram. This is our objective number 4. Are you understand?
Yes.
Yes.
And then next we have number 5, calculate the energy using the bond energies. Calculate the energy for reactant and for product. Then we will, at the end, we will predict either this reaction is exothermic and endothermic. So this is our topic today we are going to study. Are you understand the syllabus? Because I am waiting for others, so only 4 students they joined it now. I don't know what about the others actually. So I am waiting for them just for 2-3 minutes. You can read this syllabus again, and if you have any problem, you can read this syllabus, this one, that at least in your mind what we are going to study. Then inshallah we will continue now.
Mister.
Yes.
So from 1.1.1 to 1.5, the exam, the shortest.
1.1, 1.1, 1.1.2, and 1.1.53. There is a third and fourth will not come, okay?
So 1, 2, 3, 5.
1 to 5 only. 1 to 5.
Okay. Thank you.
1 to 5. Now, I want to show you now. Going to start properly because I don't know about others when they will join. Yesterday we discussed about endothermic process and exothermic process, and I uploaded this already, this slides, and you got. Now, you know, here a chemical reaction, either they release or absorb heat. We discussed yesterday, but we are going to discuss again because we need to draw the diagram. So first, exothermic reactions, we need to write a chemical reaction, reactants and products. So please focus here because we are going to calculate our next topic. But first now, reactant where we can write before the arrow, and after the arrow we can write product. Either exothermic or endothermic, the way of writing of equation is same. Reactant always your left hand side and product your right hand side. Are you okay about how to write chemical equation?
Yes.
Okay, good. Now we are going to discuss that what happened with the amount of energy during exothermic and endothermic reaction. This is our objective actually. Again, I am going to repeat. During exo and endothermic reaction, what happened with the amount of energy? Either it will decrease or increase. See here, this is our first diagram, energy level diagram for exothermic energy level diagram. This diagram maybe I will give you in your exam, and you need to predict either this diagram for exo or for endothermic, or maybe diagram given and then, or maybe you need to draw. So both possibility of question. Maybe you need to draw or maybe diagram given to you. So how you know that this diagram for exothermic and this diagram for endothermic? So please look first exothermic energy levels diagram. This on y-axis, the amount of energy is written, its unit is kilojoule. You can see here kilojoule. They start from 60 to 180. It's not necessary. You can start from 0 to 100. So on y-axis, the amount of energy. On x-axis, nothing written, but I will show you more diagram. So you will get here written reaction. On x-axis, reaction. On y-axis, the amount of energy. What happened in exothermic reaction? Amount of reactant initially amount of reactant is very high. You can see here 160 kilojoule. But when reactions start, the amount of reactant converted to the amount of product. Understand? So if reactant on the top and product in the down, an arrow going from reactant to product, this
decrease.
Excellent. So if arrow is from reactant to product, you can predict the diagram from the arrow. Okay. If reactant on the top and product is down, you can see the where is the arrow. Arrow is going up or coming down. So this arrow is going down. So this diagram for exothermic reaction. Understand how to find out either it is exo or endo?
Yes.
Good.
Yes.
Now see here written something. Delta H is negative. This is very important. Delta means change. Delta means change. Change in energy. Understand? Delta means change. This delta sign we use, this means change. H for heat. If delta H value, delta H means change in energy from reactant to product. Change in energy from reactant to product we call delta H. We denote it by delta H. Delta for change, H for heat, or you can say energy of reaction. If energy of reaction is negative, then we call this reaction is exothermic. Did you understand that?
Yes.
How to find out? First, there is a two-way. First, from the arrow. If arrow from the reactant towards product, this is exo. And second one, if delta H value given in negative sign, like delta H minus 200, minus 180, minus 822, any value given with the sign of delta H, if given in negative, reaction is exothermic. And if reactant on the top and product is down, you can find out this arrow. Arrow is going from reactant to product. So this reaction is exothermic. Now you understand how to draw diagram for exothermic reaction?
Yes.
Any problem?
No.
No.
Yes, any one of you? Can I continue the next diagram?
Yes.
Thank you. Now, next this one and written there. You can see same exothermic energy level diagram. Delta H. We saw on the previous slide, delta H is the symbol for the change in energy. In an exothermic reaction, the product having less energy than reactant. This is very important. Second point. See, product is here. Product is 80. Amount of energy for product 80 in this diagram. I told you it's not necessary that you have to start from 60. You can start from 0. But check there is product. Here the amount of product is 80, but amount of reactant is 160. So which one is greater?
Reactant.
Reactant, good. And product is smaller.
Less.
So it's point number 2 will help you to understand in an exothermic reaction, the products having less energy because it's down, less energy than reactant, and delta H is negative for an exothermic reaction. So you need these 3 points is written with the diagram. And this diagram you can draw in this way for exothermic case. Now for endothermic reaction, you can see for endothermic, reactant is down and product is up. Understand now? So what do you think? Amount of reactant is greater or product?
Product.
Product. Good, excellent. Why? Product on the top and reactant is down. If this diagram given, how you know? From the arrow.
Positive.
Okay. See this arrow. From reactant to
Product.
product. Good. And now delta H is positive or negative?
Positive.
Positive.
In case of exothermic reaction, delta H is negative. It means exothermic and endothermic both are opposite of each other. Is it?
Yes.
Yes.
Both are opposite. Clear now this one? What is the difference between exo and endothermic reaction? In
Yes.
case of endothermic, reactant is down and product on the top, and arrows from down to up. This arrow. In case of exothermic, from up to down. This is the difference between both diagrams. So how to identify either it is exothermic or endothermic? You will check first this arrow. Second things, you will check the delta H, either it is positive or negative. You can see delta H positive or negative. See this one, explanation. In an endothermic reaction, the products having more energy than reactant because it's on the top. And delta H is positive for endothermic reaction. Delta H is positive for endothermic reaction. Delta H is negative for an exothermic reaction. So there is a two main difference between exo and endo. First one, the arrow, and second one, you will check exothermic and endothermic reaction. The value of delta H is given to you. Clear, guys?
Yes.
Yes.
Okay, this is the basic concept for exo and endo. I am going to show you the more complicated diagrams and how you will understand from those. See this one? Just practice with me, please. This is the question, and like this questions, if given to you, first you need to identify this equations is for exo or for endo. Can you see this?
Endo.
Endo, excellent.
Endo.
Excellent. Now, this is the answer because reaction absorb energy. When reaction absorb energy, endothermic reaction good. If you need to draw diagram for this equations, how you will draw? Can you tell me where is the product and where is reactant, please, for this equation?
The
The
reactant
reactant is the first and on the right.
and the product, the right.
Yes.
Which one is greater, reactant or product?
Reactant.
Product,
Product.
good,
Product,
because this is
product.
endothermic. So see back again this diagram, please. This is endothermic. Endothermic, see product on the top. Because this equation, how you know this is endothermic? Because energy written in reactant side. Yesterday we practiced for this, energy written in reactant side we call as endothermic reaction. So for endothermic we have this diagram. Any problem?
No.
Okay. Let me to show you something more about exo and endothermic reaction, that at least you will get the concept. Yesterday we did, I think, this one. Who will tell me the answer of this question, please? Why must heat be absorbed in order for water to boil? Okay, so please, what is the answer?
To break the bonds of the liquid.
Excellent. Why? Because this is when absorbed, it is
Endothermic.
endothermic reaction. Excellent. Please. So what is the option? C, you can see the answer.
C.
Yes. Okay, now see, I'm going to share another screen with you. This one is very important to see the more diagram actually. I already uploaded this slides on your platform and you can see later. This diagram for endothermic reaction. You saw before, there is a simple diagram to identify either it is exo and endo, but in your exam, maybe diagram will come in this way. Don't worry, no need to get confused. Why? Because see here, where is the product? On the top or on the down? Where is
Top.
the top? Is it? You
Yes.
see this one.
Yes.
Where is written product? And where is written reactant? This is very easy to get. Reactant is down and product on the top. So if amount of product is greater than reactant. What you call?
Endothermic.
Excellent. Now they draw this line, blue line, from here towards product. This blue line actually represent only two things. First one is that energy released to bond breaking process. This black arrow, that how much energy released, but come on the left side, this black arrow we call activation energy. What is activation energy? Energy used in bond breaking. So when bond from here, this point bond start to break. And then the maximum amount of energy, this is the peak. This peak actually we called activation energy. This peak tell us that reactant now completely converted to product. Did you understand why they draw diagram like this on the peak and then decreasing order?
Yes.
Only this line, this straight line for product, this straight line for reactant, but what happened in between? We are going to study this point. From here, this point, the reaction will start and bond start now to break the bond from this point, and this is the maximum point. You can see the peak. This point completely reactant converted into product. And when reactant converted to product, formation of new bond we call exothermic. And when we need energy to break the bond, we call endothermic. So within a diagram, they show by either it is exo or endothermic in both way. Now you can read this one, endothermic, more energy is taken to break the bond. You can see more energy is taken to break the bond. This black arrow is higher than this smaller. Okay, bonds in the reactions then released by the bond being formed. See this arrow, this one is small as compared to this black arrow. So here we need more energy to break the bond. Here less energy will release when new bonds will form. Then you can say therefore energy is absorbed, more energy absorbed. If more energy absorbed, we call reaction is endothermic, and energy absorbed in a chemical reaction when bond start to break. Now, this you saw yesterday. Now, this is the second diagram for exothermic reaction. Where is the reactant? On the top. Where is the product? On the top. You have to find out from reactant to product. This is exothermic. But similar situation you understood from reactant start from here to break the bond, and then this is the maximum energy we call activation energy when reactant converted into product. So here reactant is greater than product, more energy is released when the product were formed than energy was used to break the bond. You see this energy used to break the bond, but more energy will release from this point. More energy will release when product will form. So if diagram like this, are you able to identify it is exo or endo?
Yes.
Yes.
And these two, I want to show you another diagram. It's very simple and very easy, and maybe in exam the question will come this way. Let me to share with you that diagram, and you need to read it. See this one. If question come in your exam, this first diagram, reactant here and product on the top. And this diagram for endothermic reaction. See that this is the comparison, because before you saw the different slides. Now both diagram in front of you. Then you compare yourself, please, that how you know is it exo or endothermic, or this diagram for exothermic or endothermic. Maybe these diagrams given to you you need to write or you need to identify this first diagram for exo or maybe for endo. So see here, from where you will write, see the where is reactant, where is product. If product is greater than reactant, endothermic. If reactant is greater than product, then is exothermic. Other things are written, energy is taken in to break the bond. You saw before, energy is released from this point is the maximum point we called activation. But when you are going to down in decreasing order, that amount of energy is given out by bond making. So here red one, this red lines is represent exothermic part and this blue one is endothermic part within a diagram. C for exothermic reaction, reactant on the top and this is the product now. Here energy taken in by bond breaking. This blue arrow, how much energy needed to break a chemical bond we call endothermic, and this red line energy is given out by bond making. So this actually this curve you can see, don't worry about this curve, only represent that when bonds start to break and what is the ending point of that. That's it. But you need to be focused where is reactant and where is product. So this is very simple. For endothermic, product is greater than reactant, and for exothermic, reactant is greater than product. Read this one, please. Everything is explanation given these 4 points. Read and then tell me if you have any question, please. Any question, please?
No, mister, thank you.
No.
Okay, good. No. Come back to this diagram and I'm going to show you from your chemistry book. See now. Chemistry grade 10 exothermic, as I told you, the topic number 9.1 we finished yesterday about exothermic. And see this diagram. You can get this diagram from your chemistry book. So there is objective, I told you, the second objective, if data given to you. If data given to you, you need to draw the diagram according to that information. So see here, the energy change for reaction F above this one. Calcium carbonate, when break down, you will get calcium oxide and carbon dioxide. The energy change means delta H value given in positive sign. What do you think this reaction exo or endo if energy amount of energy given in positive?
And thermic reaction.
Endothermic reaction.
Exothermic.
So 178 kilojoules of energy is needed to break a chemical bond. So the amount of energy 178, but in positive sign. If delta H given in positive sign, then exothermic or endothermic?
Endothermic.
Excellent. Endothermic. So if this diagram, see here, the plus sign shows the energy is taken in. So Maybe in an exam, you will get question like this. Diagram or equation will give you. Then you need to check the equation, either this equation for exo or endothermic. See here for endothermic, then they draw this diagram. You know that if endothermic, where you have to write this calcium carbonate here in reactant place. So instead of this word, you will write CaCO3. Understand? And then
Yes.
draw this arrow from reactant to product. Draw this arrow from reactant to product. And then remove this word product and then write the place of product calcium oxide plus carbon dioxide. So sometimes equations given to you, you need to draw diagram according to equation. So what you will do, just remove this reactant word and instead of reactant, write from the equation what is given here before the arrow. And then remove this word product, then write what is given here in product side. Here product side, here given CaO plus CO2, just you write here same CaO plus CO2. That's it. And arrow will remain same because this is endothermic reaction. Clear now?
Yes.
Okay. You will read later. Now we are going to these questions you can solve if any problem. I will explain for you. Let me to check actually. I want to show you another topic. Only 7 minutes left in your lesson further. Next, our topic is bond energies. How to calculate? Calculating the energy change in a chemical reaction. This will come in your exam. Calculating the energy change in a chemical reaction. See, this table I will provide you. No need to memorize this table. The bond energy in kilojoule per mole. No need to memorize. I will give you even in your short test. I will give you this table with the short test, or I will write the value. Then what you will do in calculation actually, the bond energy is the energy needed to break a bond or release when these bonds form. It is given in kilojoule. This table energy given in kilojoule. Now, what is the formula? How you will calculate? This will later I will show you. But see, calculating the energy change in a chemical reaction. This is first example. Focus here, please. A reaction is given to you. This one H2 plus Cl2 gives us 2HCl. So first we will calculate for left hand side this reactant side, then we will calculate for product side. So we have two sides, left hand side and right hand side. Let's calculate for left hand side. You know that in reactant bond will break down. So energy into break each molecule of bond. So H and H, only one. If nothing written before this, it's mean one. They write here 1 times, they will multiply. How many bonds between H and H? One bond here. So the amount of energy is 436. From where they will get this 436? You can see the amount of energy for H and H is 436. This I will give you. You need to just check that how many bonds are there. This how many bonds? If one bond, you will write same. Because C and Cl, another. See this equation, nothing written before C and Cl. It's mean 1. Now they will multiply with C and Cl. So what is the amount of energy needed for one bond between C and Cl, between chlorine and chlorine? You can check here, the second bond. 242. So you have to write same because only a single bond, they wrote here 242. Now, what is the sign in between H and Cl? Positive. So what you will do, add up both. 678 kilojoule. Understand how to calculate?
Yes.
Okay. Now we have second part, please. energy out from the two molecules. See here HCl2. That's why we need to write here 2 times H and Cl. So we will check in table what is the amount of energy for H and Cl. Go back, check energy for H and Cl, given is 431. So multiply 2 with 431. See, you will get 862. Now, product side 862, reactant side 678. So how you will calculate delta H value? This is the rule. Energy in main reactant minus energy of main product. So reactant 678 minus product we got 862. Our answer is minus 184. This minus sign indicates the reaction is exothermic. Understand?
Yes.
Okay.
Yes.
Last 2 minutes, please. See if you need to draw diagram for this reaction. So see where is HNCl? This equation, please. See H2 plus Cl2 in reactant side, they wrote here H2 plus Cl2. Then arrows is going up and then they write 2HCl. So you can write here. See, this is reactant. Then here bond will break down and then it is converted into product. This green arrow now represents 2HCl. Why? Reactant is greater than product. Why? Because we know here negative sign, so reaction is exothermic. Another example given, please practice this one or next class we will. If you have any problem, you can ask question. Okay. Hope you will understand. Inshallah, next class we will continue. Anyone of you?
What, mister?
Okay, bye. Next class.
Bye.
mister.
Bye.
Thank
Bye,
you.
mister.
Thank you.
Welcome all of you.
Thank you.